हेलो चेक चेक। हेलो दोस्तों, वेलकम टू गेट वाला। मैं हूं सतीश कुमार द्रिशेट्टी। कैसे हो सब लोग? आज हमने कंप्यूटर ऑर्गेनाइजेशन आर्किटेक्चर के बारे में फर्स्ट लेक्चर स्टार्ट कर रहे हैं। जितने लोग लाइव में हैं मुझे एक बार ऑडियो वीडियो का कंफर्मेशन कर दीजिए फटाफट। ये टॉपिक ईसी लोगों के लिए है, गेट इलेक्ट्रॉनिक्स एंड कम्युनिकेशन लोगों के लिए है, सीएससी के लिए नहीं है। ओके, मैं पहले ही मैं आपको इंफॉर्मेशन दे रहा हूं। ये दिस पर्टिकुलर टॉपिक इज फॉर गेट ईसी, गेट इलेक्ट्रॉनिक्स लोगों के लिए है। आवाज, ऑडियो, वीडियो सब कुछ क्लियर है सो दैट वी कैन स्टार्ट द सेशन। एंड हाउ मेनी ऑफ यू आर हियर ईसी स्टूडेंट्स? प्लीज शो योर थम्स अप। जितने लोग ईसी स्टूडेंट्स है एक बार मुझे थम्स अप दिखाइए। या आपको पता है ये पर्टिकुलर टॉपिक COA, कंप्यूटर ऑर्गेनाइजेशन एंड आर्किटेक्चर, so this particular topic is added as a part of digital electronics. I think all of you are following. I think many of you have followed the digital syllabus. अगर डिजिटल सिलेबस देखें तो डिजिटल इलेक्ट्रॉनिक्स में लास्ट पार्ट इज गिवन एज कंप्यूटर ऑर्गेनाइजेशन एंड आर्किटेक्चर। ओके, सो आज का सेशन है एक्चुअली मिशन इंस्ट्रक्शंस इज द फर्स्ट टॉपिक, लेकिन फर्स्ट मैंने थोड़ा सा इंट्रोडक्शन देना चाहता हूं। इंट्रोडक्शन में what is the basics of computer components, what is actually computer architecture and organization, थोड़ा सा थियोरेटिकल व्यू में जाएंगे, फर्स्ट कंपोनेंट्स में जाएंगे, उसके बाद जो कुछ एक्स्ट्रा टॉपिक्स है, ओके, व्हाट आर द एक्चुअल टॉपिक्स है गेट के लिए, कैसा आ सकता है। पहले हमको इलेक्ट्रॉनिक्स एंड कम्युनिकेशन लोगों के लिए पहले उसमें माइक्रो प्रोसेस का सिलेबस था। माइक्रो प्रोसेसर का सिलेबस का प्लेस में अभी कंप्यूटर ऑर्गेनाइजेशन आर्किटेक्चर ऐड किया है। सीएससी के लिए भी बेनिफिशियल होगा, लेकिन सीएससी के लिए सिलेबस ज्यादा है। सीएससी के लिए सिलेबस ज्यादा है, सीएससी के लिए से कोर सब्जेक्ट है। लव ये ईसी लोगों के लिए एड ऑन सब्जेक्ट है, थोड़ा सा डेप्थ इतना नहीं होगा सीएससी के लिए। ओके, चल चलो माय डियर, आज का टॉपिक्स क्या है? आज का टॉपिक्स मैं डिस्कस करना चाहता हूं, ये है हमारा आज का एजेंडा है, व्हाट इज कंप्यूटर आर्किटेक्चर। क्योंकि पहले बार ईसी लोगों के लिए सीएससी सब्जेक्ट ऐड हो चुका है। आजकल गेट का सिलेबस में स्लोली स्लोली कंप्यूटर्स का सब्जेक्ट आ रहे हैं। ओके, चल फॉर एग्जांपल इफ यू टेक गेट इंस्ट्रूमेंटेशन, उनको माइक्रो कंट्रोलर्स, एम्बेडेड सिस्टम्स भी आ चुका है गेट का सिलेबस में। ओके, एंड ईसी के लिए ये आ गया कंप्यूटर आर्किटेक्चर। प्लीज गो थ्रू आज का एजेंडा। आज का एजेंडा है, बिफोर स्टार्टिंग द एक्चुअल टॉपिक, ओके, सी इफ यू सी द सिलेबस, एक्चुअली सिलेबस क्या है? See my dear, as per the syllabus for GATE ECE, what are the topics given in the COA? Directly they have given mission instructions, उसके बाद addressing modes, and ALU, CPU, data path, and they have given some concepts of pipelining. This is the topic for COA. If you check the syllabus, एक बार EC का syllabus check कर दो बेटा. I will be taking 5 sessions almost every day. I will be taking 1.5 hour maximum. 1.5 hour session का दे रहता है. Almost I will take 5 sessions. That means around will cover 8 hours, 8 to 10 hours. Okay ना? 8 to 10 hours का सेशन होता है. पूरा कंप्यूटर ऑर्गेनाइजेशन ईसी लोगों के लिए क्या आ सकता है उसके ऊपर हम चर्चा करेंगे. So first of all, you have an idea. These are the small topics added in the syllabus: machine instructions, addressing modes, ALU, CPU, data path, pipelining. बेटा एक्चुअली इसी बच्चे सोचते हैं थोड़ा सा डिफरेंस होगा माइक्रो प्रोसेसर से, क्योंकि एक सम टॉपिक्स माइक्रो प्रोसेसर में भी है आपको पहले. व्हेन यू आर स्टडिंग द 8085 और व्हेन यू आर स्टडिंग 8086 माइक्रो प्रोसेसर, आपके साथ थोड़ा टॉपिक्स हैं. एड्रेसिंग मोड्स आपने सुन लिया है माइक्रो प्रोसेसर का टॉपिक में. यस, ऑलमोस्ट सेम रहता है, बस just with respect to architecture there is a small difference. So I want to focus more on the differences so that आपको clarity मिलता है. What is the difference between the computer organization and architecture and instruction set with respect to COA subject with respect to microprocessor. Microprocessor में आपका जो कुछ भी instruction set है that will be specific to your microprocessor. Yes or not? अगर वो 8085 microprocessor use करे तो आप में MVI बोलते हैं, move immediate बोलते हैं. When we are going for 8086 आपने move instruction बोलते हैं. ओके, अगर प्रोसेसर का आर्किटेक्चर चेंज हो गया अकॉर्डिंगली इंस्ट्रक्शन का प्लान भी चेंज हो जाएगा. बट ये कंप्यूटर ऑर्गेनाइजेशन आर्किटेक्चर इज ऑल अबाउट डिजाइनिंग एन आर्किटेक्चर विच ए प्रोसेसर कैन फॉलो. ओके, सो फर्स्ट ऑफ ऑल हमको बेसिक से जाएंगे, वेरी वेरी बेसिक लेवल से, क्योंकि लास्ट ईयर में आपको क्वेश्चंस कुछ भी नहीं आया. आई थिंक वेरी वेरी ऑलमोस्ट आई डिडंट फाइंड एनी क्वेश्चंस actually from computer organization architecture from the last year, but as it is there in the syllabus we should go through the content. and जो ये free sessions है ना, आपको YouTube में sessions है, मैं maximum justice करने की कोशिश करता हूँ. यही sessions में आपको पूरा content आपको मिलेगा, यही content से आप GATE exam को जा सकते हैं बिल्कुल. and you no need of any other extra preparation. I will cover the maximum extent. okay my dear. yes, Saturday Sunday को भी होगा session. चलो फर्स्ट हम स्टार्ट करेंगे. प्लीज ऑल ऑफ यू जल्दी से जल्दी नोट्स, प्लीज कीप द नोट्स. सीरियस एस्पिरेंट्स होना चाहिए मेरे क्लास में इंटरेक्शन होना चाहिए, अच्छा इंटरेक्शन. एट द सेम टाइम द टाइम इज मोस्ट इंपॉर्टेंट फॉर मी एंड द टाइम इज मोस्ट इंपॉर्टेंट फॉर यू. प्लीज आज का एजेंडा है, आज का टॉपिक ये है. मैक्सिमम ट्राई करेंगे, कोशिश करेंगे पूरा टॉपिक को डिस्कस करने के लिए. बेसिक से जाएंगे क्योंकि समटाइम्स ऐसा टॉपिक्स ऐसा सब्जेक्ट्स में आपको MSQ बहुत सारा आने वाला चांसेस है, मल्टीपल सेलेक्ट क्वेश्चंस. तो फर्स्ट टॉपिक है कंप्यूटर आर्किटेक्चर, नेक्स्ट टॉपिक है कंप्यूटर ऑर्गेनाइजेशन. बेसिकली कंप्यूटर आर्किटेक्चर क्या होता है, कंप्यूटर ऑर्गेनाइजेशन क्या होता है, उसमें बीच में डिफरेंस क्या है. नेक्स्ट द डिफरेंसेस कंप्यूटर आर्किटेक्चर वर्सेस कंप्यूटर ऑर्गेनाइजेशन. एंड इसके बाद वॉन न्यूमन वर्सेस हार्वर्ड आर्किटेक्चर. द वेरी फर्स्ट आर्किटेक्चर्स डेवलप्ड वॉन न्यूमन वर्सेस हार्वर्ड आर्किटेक्चर. उसके बाद सिस्क वर्सेस रिस्क. जितने लोग ये क्लास में है, आई थिंक दे हैव लिसन्ड दिस, दे हैव गॉट दिस सिस्क एंड रिस्क समवेयर इन द electronics communication whenever they are studying the subjects like embedded systems, subjects like 8051 microcontroller, subjects like any DSP subject, they may get these topics. Can you write anybody? CISC बोलो तो क्या है, RISC बोलो तो क्या है? I'm expecting the answers from your side. Please सेशन को लाइक कर दीजिए, सेशन को थोड़ा एनर्जेटिक होना चाहिए. What is the concept? What is the full form of CISC and RISC? जल्दी everybody please type what is a full form of CISC and RISC. नेक्स्ट उसके बाद आज का टॉपिक गेट का टॉपिक एक्चुअली मशीन इंस्ट्रक्शंस. यहां से मशीन इंस्ट्रक्शंस एक्चुअली गेट का टॉपिक है, लेकिन इसके पहले थोड़ा इंट्रोडक्शन होना चाहिए. सो मैं पहले थोड़ा इंट्रोडक्शन देने के बाद डायरेक्टली मैं मशीन इंस्ट्रक्शंस को जाना चाहता हूं. आई एम नॉट गेटिंग एनी आंसर फ्रॉम योर साइड. आई एम एक्सपेक्टिंग द आंसर फ्रॉम योर साइड. व्हाट इज द फुल फॉर्म ऑफ CISC एंड RISC माय डियर? CISC क्या है, RISC क्या है? क्या कोई सिंगल आंसर भी नहीं आए? इलेक्ट्रॉनिक्स के बच्चों आपको पता होना है CISC एंड RISC. आई थिंक यू हैव अ कंपनी आल्सो, सिस्को. No answer, no single answer. What is the full form of CISC and RISC? Vinay Pratap, Divakar, Yashikumar, Pragati, very good. Complex instruction set of computers. Okay, so what is a CISC? इसका full form क्या है? Complex instruction set computer. Next, RISC बोलो तो reduced instruction set computer. Okay, complex instruction set computer, reduced instruction set computer. Okay, चलो, first of all, what is the computer architecture? Computer architecture बोलो तो क्या है? Because CA, computer architecture is what actually? See, computer architecture क्या डिस्कस करता है? कंप्यूटर आर्किटेक्चर ये डिस्कस करता है, सपोज आप ऐसा इमेजिन कर लो, आप बड़ा आर्किटेक्टर हो, यू आर आर्किटेक्ट, if you are an architect, how you will design a computer for a particular purpose. Okay, so computer architecture, it's a blueprint, of design of your computer. Listen, and it always decides, computer architecture deals with what to do, what this architecture has to do, what is the purpose of this architecture. Okay, and suppose it is having certain blocks, एक कंप्यूटर के अंदर कुछ ब्लॉक्स हैं, एक कंप्यूटर का ब्लॉक्स जो कुछ है, वो ब्लॉक्स को फंक्शनलिटी कैसा होना है, 8 बिट आर्किटेक्चर होना है और 16 बिट आर्किटेक्चर होना है. अगर आपने 16 बिट अरिथमेटिक ऑपरेशन, आई थिंक सम बेसिक्स यू हैव, आई होप some most of all the students are from ECE background, they have studied microprocessor subject, I know they know what is bit to byte word everything basics. अगर आपने 8 बिट माइक्रोप्रोसेसर, अगर आपने 8 बिट अरिथमेटिक ऑपरेशंस करना चाहते हो, अगर आपने 8 बिट अरिथमेटिक ऑपरेशन करना चाहते हो, उसके लिए बैकग्राउंड में कैसा होना है, व्हाट टाइप ऑफ रजिस्टर्स होना है, व्हाट टाइप्स ऑफ ऑर्गेनाइजिंग यूनिट होना है, व्हाट टाइप ऑफ फंक्शनल ब्लॉक्स होना है. अगर आपका विश इज डिफरेंट, आपका प्लान इज डिफरेंट, अगर आपने 16 बिट अरिथमेटिक ऑपरेशंस करना चाहते हो, 16 बिट अरिथमेटिक ऑपरेशन करने के लिए क्या फंक्शनल यूनिट्स चाहिए. So this is what actually what to do. Computer architecture, it's a conceptual design and fundamental operational structure. Okay ना? So इसमें क्या क्या आएगा, इसमें basically CPU आएगा architecture में, and type of CPU, what type of CPU it should be, what type of CPU, whether the CPU should support 8 bit CPU आ, 16 bit CPU आ, 32 bit CPU आ, उसके लिए उसके अंदर क्या आर्किटेक्चर होना है, एंड इसका बेसिक अरिथमेटिक लॉजिक यूनिट कैसा होना है, उसका ब्लॉक्स कैसा होना है. ये अरिथमेटिक लॉजिक यूनिट शुड सपोर्ट एडिशन, सब्ट्रैक्शन, और इट आल्सो शुड सपोर्ट मल्टीप्लिकेशन और डिवीजन. ऐसा इसके लिए क्या आर्किटेक्चरल फीचर्स होना है. अगर आपने ये प्रोसेसर यूज करके अगर आपने मल्टीप्लिकेशन करना चाहते हो और डिवीजन करना चाहते हो, उसके लिए क्या एडिशनल फंक्शनल यूनिट्स ऐड करना है, what to do, and these all will come under computer architecture, my dear. So computer architecture deals with what to do. If I am saying 8 bit architecture, इसका मतलब है it is performing 8 bit arithmetic operation. सबको पता हो गया भी. So आपको clear cut clarity आएगा when you start about the computer organization. What is computer organization? Computer organization is how operational parts of computer system are interfaced. जो कुछ कंप्यूटर है, कंप्यूटर का ऑपरेटिंग पार्ट्स रहता है, इनपुट आउटपुट डिवाइस रहता है, मेमोरी रहता है, रैम रोम रहता है, आईओ डिवाइस रहता है, इंटरप्ट कंट्रोल्स रहता है. इन डिवाइस को, इन पर्टिकुलर ब्लॉक्स को कैसे ऑर्गेनाइज करना है, 1-to-1 कम्युनिकेशन कैसे एस्टैब्लिश करना है, कभी इसको स्विच करना है, कभी स्विच ऑफ करना है, हाउ टू मेक प्रोग्रामिंग ऑफ द आईओ डिवाइसेस, हाउ टू मेक इंटरप्ट आईओ, हाउ टू ऑपरेट और हाउ टू ऑर्गेनाइज all these devices in a hierarchical way, that is what we call computer organization. Computer organization deals with how to do. Computer architecture deals with what to do. Computer organization deals with how to do. आपको पता चला, computer organization deals with the physical devices and their interconnectivity. Please make a note of this point, क्योंकि इसी बच्चों के लिए ये बहुत इंपॉर्टेंट है. इसी बच्चों के लिए बहुत इंपॉर्टेंट। इंटरप्ट इंटरकनेक्टिविटी बोलो तो क्या है, क्या क्या आएगा? सपोज इफ यू हैव ए सीपीयू, okay, if you have a CPU, my dear, so this is a CPU and this is a RAM and this is a ROM and this is a IO devices and this is external peripherals. Okay, see for example this is a CPU, so this is RAM, this is ROM. Okay, so this is IO devices, this is some external like our PPI, parallel peripheral interface, like DMA controller. ओके ना, दिस इज प्रायोरिटी इंटरप्ट कंट्रोलर। ऐसा डिफरेंट ब्लॉक्स है। ये दोनों के बीच में कैसा ऑर्गेनाइजेशन होना है, व्हाट टाइप ऑफ ऑर्गेनाइजेशन शुड बी देयर एंड व्हेन टू यूज, वेयर टू यूज, कैसा यूज करना है, ये पूरा CO में आएगा। अभी पता हो गया आपको कंप्यूटर आर्किटेक्चर, कंप्यूटर ऑर्गेनाइजेशन के बीच में डिफरेंस क्या है। ऑल ऑफ यू गॉट द आइडिया माय डियर। जितने लोग सेशन में है सेशन को लाइक कर दीजिए, सेशन में आंसर कर दीजिए। All of you got now clarity between computer architecture and computer organization, my dear. Everybody, please respond. Please respond, my dear. Computer architecture में क्या होगा, computer organization में क्या होगा? Computer organization majorly discusses with the interconnectivity of the blocks. Computer architecture is a blueprint or a plan of what to do. Okay, yes, thank you. See, I have given certain points so that easily you can remember. These certain points are very very important. आप नोट्स मेंटेन कर दीजिए अच्छी तरफ से। आप क्लास होने के बाद मैं पीडीएफ भी शेयर करता हूं, क्लास का पीडीएफ, एंड एवरी क्लास एंडिंग में अगर पूरा क्लास अटेंशन में पढ़े तो आपको क्लास एंडिंग में आपको डीपीपी भी मिलेगा ऐप पर। पीडब्ल्यू का ऐप है, गेट वाला का ऐप है, उसके ऊपर आपको डीपीपी मिलेगा। ओके, वो डीपीपी जरूर आप प्रैक्टिस करना है। एंड बाय द टाइम नेक्स्ट टाइम यू आर कमिंग टू द क्लास, यू हैव टू पोस्ट योर डाउट्स ऑफ द डीपीपी इन द यूट्यूब सेम कमेंट्री बॉक्स। ये क्लास होने के बाद जनरल कमेंट सेक्शन में आप कमेंट बोल सकते हैं डीपीपी में क्या क्वेश्चन डाउट है आपके लिए। ओके ना, सो दैट वो डीपीपी डाउट्स जो कुछ है मैंने नेक्स्ट कंसेक्यूटिव क्लास में अंत में मैं डिस्कस करता हूं। ओके माय डियर, ये म्यूचुअल अंडरस्टैंडिंग होना है हमारा बीच में। एवरीबडी whoever are attending in this class, at the end of the class they have to collect this PDF notes। ये बहुत श्रम से, बहुत अच्छी कॉन्सेप्चुअल राइटिंग से मैंने कलेक्ट किया है ये पर्टिकुलर डाटा को, सो दैट आपका टाइम सेव होगा। आपके लिए गेट के लिए जो कुछ समय है, वैल्यूएबल टाइम है, ये वैल्यूएबल टाइम सेव होगा। जरूर आपने ये PDF को कलेक्ट कर दीजिए। एट द सेम टाइम एट द एंड ऑफ द सेशन आपको डीपीपी मिलेगा, और डीपीपी को भी कलेक्ट कर दीजिए। यस सर, नो, सही है, कलेक्ट करते हैं बेटा। ऑल ऑफ यू प्लीज प्लीज मेक, I don't understand you. See what I mean to say, this particular class whatever I am discussing, this PDF will be available. What, why, when? This PDF will be available, my dear. This PDF will be available at the end of the class. At the same time, DPP, daily practice paper, उसको हम बोलते हैं daily practice paper. Okay, daily practice paper. See here, what is a computer architecture? Computer architecture का meaning क्या है? Computer architecture explains what a computer should do. Suppose if I am talking about architecture of, I want to design a computer which is able to perform 8-bit operations only. I think all of you know 8085 and 8086. 8085 microprocessor क्या करता है? 8085 microprocessor क्या करता है? 8085 microprocessor is all about the arithmetic operations, right? So this architecture, इसका पीछे architecture कैसा डिजाइन करना है? It is only for arithmetic operations and subtractions and subtraction, addition, only for 8-bit operations. So that is what to do. And computer organization explain how a computer operates this, and it provides the functional behavior of the computer system. Just it provides a functional behavior, how a CPU should operate, how a clock, how that particular memory should operate, and but how to interact with them, what is the interconnectivity with them, when to organize, that will come under computer organization. It understands the structural relationships between the parts of the computer system. Please make a note of this. Parts of the computer system. So जो हमने मैंने बताया, जो कुछ आपने interfacing of this particular RAM to CPU, connection of DMA controller to CPU, okay na, interrupt driving mechanism, communication between the IO devices, XYZ, keyboard, mouse to the CPU, ये पूरा कंप्यूटर ऑर्गेनाइजेशन में आएगा. ओके, डिजाइन ऑफ सीपीयू का आर्किटेक्चर कैसा होना, अरिथमेटिक ऑपरेशन सपोर्ट करना, 8 बिट का, 16 बिट का, 32 बिट का, दैट इज कम्स अंडर आर्किटेक्चर माय डियर. कंप्यूटर आर्किटेक्चर डील्स विथ हाई लेवल डिजाइन. हाई लेवल बोलते क्या है, उसका सीपीयू कैसा होना है, उसका एएलयू कैसा होना है, एएलयू में डिकोडिंग एंड कंट्रोलिंग एंड सर्क्यूटरी यूनिट कैसा होना है, ये पूरा कंप्यूटर आर्किटेक्चर में आएगा. कंप्यूटर ऑर्गेनाइजेशन डील्स विथ लो लेवल डिजाइन. लो लेवल डिजाइन बोलो तो एट द एंड आईओ डिवाइस को कैसे कनेक्ट करना, डीएमए कंट्रोल को कैसे करना, माउस को कैसे कनेक्ट करना, एंड व्हेन द प्रिंटर इज गोइंग टू बी कनेक्टेड, व्हाट आर द कमांड्स, व्हाट इज द ऑर्गेनाइजिंग बॉडी, सो दैट ऑल विल कम अंडर लो लेवल डिजाइन. नेक्स्ट, what is the design actors here? Major actors कौन है? It actors in computer architecture are hardware parts. Okay, hardware parts. CPU is a hardware, touchable parts. These are all architectural. Okay na? And actor in computer organization is a performance. I want to improve the performance. I want to save the time of CPU access for the IO device. That's why I bring the DMA controller. These all will come under organizing the things, organizing the body. Okay na? Computer architecture is designed first. After the design of computer architecture, computer organization is started. First architecture को डिजाइन करो, आर्किटेक्चर को डिजाइन करने के बाद ऑर्गेनाइजेशन आएगा. सबको पता हो गया अभी. सपोज once I decided 8-bit architecture, for example 8085 माइक्रोप्रोसेसर मैंने चूज किया, इट्स a 8-bit architecture. 8-bit architecture में मैंने एडिशन सब्ट्रैक्शन कर सकता हूं, मल्टीप्लिकेशन डिवीजन नहीं कर सकता हूं. अगर मल्टीप्लिकेशन डिवीजन करना चाहे तो देयर इज अ सेपरेट मेथोडोलॉजी, separate organization for it. So all of you understood, my dear? Everybody got the clarity between architecture and organization? Pooja Kumari, Deepa, everybody. Chalo. Please listen carefully and collect and please follow these notes carefully. First 2 chapters से आपको बहुत सारा theoretical bits आने वाला है. This topic majorly is having certain theoretical concepts को बहुत अच्छा ध्यान से सुनो. चलो. Next one example देता हूं मैंने कंप्यूटर आर्किटेक्चर्स में. There are 2 famous architectures, my dear. There are 2 famous architecture. I think all of you know it. The first famous architecture, which is the oldest architecture, and till today also many computers are using this architecture. What is that architecture? That is a von Neumann architecture. What is the fundamental feature of von Neumann architecture? Von Neumann architecture is nothing but stored program concept को use करते हैं. Stored program concept. What concept use करते हो? Stored program concept को use करते हैं. That means what? Actually, I think all of you have some basic idea. There are 2 types of memory. जहां मैंने डाटा स्टोर करता हूं और जहां मैंने कोड, प्रोग्राम कोड को स्टोर करता हूं. जनरली हमने क्या बोलते हैं, वेयर यू आर स्टोरिंग द डाटा उसको हम बोलते हैं डाटा मेमोरी बोलते हैं. वेयर एक्चुअली यू आर स्टोरिंग द प्रोग्राम उसको कोड मेमोरी बोलते हैं. Suppose you don't have a separate space, you are mixing both data memory and code memory together. That means the program memory is also stored in data memory. Then उसको हम बोलते हैं von Neumann architecture बोलते हैं. Understood this point, my dear? Most expected fundamental question है. von Neumann architecture में क्या होता है? Stored program concept रहता है, उसमें data memory and code memory together रहता है. सेपरेट मेमोरी नहीं रहता है. स्पेस का कंजम्पशन कम होता है, इसलिए डाटा मेमोरी एंड कोड मेमोरी टुगेदर रहता है. ओके, सो दैट इज व्हाट वी कॉल, सी हियर, इफ यू सी von Neumann आर्किटेक्चर, द फंडामेंटल आर्किटेक्चर, इसमें क्या क्या है? एक इनपुट डिवाइस है, एक आउटपुट डिवाइस है, एक सेंट्रल प्रोसेसिंग यूनिट है. इफ यू सी द सेंट्रल प्रोसेसिंग यूनिट, इसमें अरिथमेटिक लॉजिक यूनिट है. इट इज हैविंग अ सेट ऑफ रजिस्टर्स. प्लीज ऑल ऑफ यू मस्ट एंड शुड हैव एन आइडिया. सेंट्रल कंट्रोल यूनिट क्या करता है, अरिथमेटिक लॉजिक यूनिट क्या करता है, आपको पता है. अरिथमेटिक लॉजिक यूनिट विल परफॉर्म द बेसिक अरिथमेटिकल ऑपरेशंस लाइक एडिशन, सब्ट्रैक्शन, मल्टीप्लिकेशन, डिवीजन, लॉजिकल ऑपरेशंस लाइक एंड और एक्सऑर, नॉट, नेगेट. एंड इसको ऑपरेशन को परफॉर्मेशन करने के लिए, डाटा स्टोरेज करने के लिए इंटरनली थोड़ा टेम्पररी मेमोरी लोकेशन है. those temporary memory locations को not temporary, we should not use a temporary memory location, they are permanent memory locations, but where the data is stored temporarily. Okay na? Permanent memory locations inside the CPU. Why? Because every time I cannot go to the memory to collect the data, so I will use a set of registers. Fundamentally, whatever may be the processor, my dear, जितने लोग इधर 8085 को follow किया, 8086 को follow किया, 8051 को follow किया, fundamentally computer architecture and organization is not specific to one program or one type of microprocessor. It is a generalized way. Whatever may be the processor or whatever may be the controller that you are using, my dear, fundamentally it is having some set of registers. Please note on the registers. The registers are PC, next AC, next MAR, next MDR, next CIR. Okay, so these are the fundamental. See, my dear, computer organization deals with, okay na, or computer architecture deals with not specific to one processor. That is what I want to say. Okay na, don't think it is only specific to one type of processor. It's a generalized. From this architecture only different processors are to follow. Okay, so these are some general set of registers. What is a PC, my dear? PC, I think everybody knows. What is a PC? PC बोलो तो क्या है? PC आपने पढ़ चुका है, प्रोग्राम काउंटर बोलते हैं उसको. क्या बोलते हैं? प्रोग्राम काउंटर बोलते हैं. AC को क्या बोलते हैं? अक्यूमुलेटर बोलते हैं. इट इज अक्यूमुलेटर. एंड MER को क्या बोलते हैं? मेमोरी एड्रेस रजिस्टर बोलते हैं. मेमोरी एड्रेस रजिस्टर बोलते हैं. MDR को क्या बोलते हैं? मेमोरी डाटा रजिस्टर बोलते हैं. मेमोरी डाटा रजिस्टर बोलते हैं. एंड CIR को क्या बोलते हैं? करंट इंस्ट्रक्शन रजिस्टर बोलते हैं. करंट इंस्ट्रक्शन रजिस्टर बोलते हैं. प्लीज नोट डाउन, माय डियर. ओके ना एवरीबॉडी? उसमें से आपको एक बिट आने की पॉसिबिलिटी है. दिस आर जनरल रजिस्टर्स. ओके ना, प्लीज मेक अ नोट ऑफ दिस पॉइंट्स. See, I have collected the information here just for your idea. Everybody noted? Chalo, let us move for this now. So what is a von Neumann architecture? Von Neumann architecture is basically on the stored program concept, my dear. It is basically on what? Stored program computer concept. That means the program memory and data memory both are in the, so fundamentally what? The program memory and data memory both are in the same memory. Program memory and data memory both are in the same memory. What is the problem if I have like this? Anybody can tell me? If I have program and data together in the same memory, what is the problem? Is there any problem? What is the advantage and what is the disadvantage? Advantage क्या है? Space consumption कम हो गया. Program के लिए separate memory, data के लिए separate memory का possibility से हमने मुफ्त हो गया, इधर थोड़ा सा profit है उसमें. लेकिन डिसएडवांटेज क्या है? डिसएडवांटेज क्या है? उसको एक्सेस करने के लिए आपके पास जो कुछ बस है उसको शेड्यूलिंग करना पड़ेगा. डू यू हैव कॉन्सेप्ट ऑफ बस? एड्रेस बस, डाटा बस, कंट्रोल बस, राइट? सो ये बसेस को शेड्यूलिंग करना पड़ेगा. व्हाई? बिकॉज इफ योर एड्रेस बस, डाटा बस इज डीलिंग विद द प्रोग्राम मेमोरी, देन यू हैव टू वेट फॉर द डाटा मेमोरी. सो यू हैव टू मेक certain scheduling. To make scheduling, you need to design certain algorithms. When address and data memories, address and data buses have to access this program memory and data memory. Yes or not? Do you agree this? So von Neumann architecture is based on the stored program computer concept, where instruction data and program data are stored in the same memory. This design is still used in most of the computers today. Even though it is slower, it is still used in the computers today. So what are the basic features? CPU का मतलब क्या है आपको पता है. CPU is electronic circuit responsible for execution of the instruction. Sometimes ये CPU को ही हम क्या बोलते हैं, sometimes this particular CPU को भी हमने माइक्रोप्रोसेसर बोलते हैं. CPU को हमने बोलते हैं माइक्रोप्रोसेसर. मेरा ये क्वेश्चन है, माइक्रोप्रोसेसर is having inbuilt memory or not? Does the microprocessor will have inbuilt memory? माइक्रोप्रोसेसर के साथ इनबिल्ट मेमोरी रहता है क्या? आंसर कर दीजिए. जनरली हमने सीपीयू को प्रोसेसर बोलते हैं, लेकिन ये प्रोसेसर को इनबिल्ट मेमोरी रहता है क्या? प्रोसेसर के अंदर इनबिल्ट मेमोरी रहता है नहीं. प्रोसेसर डज नॉट हैव मेमोरी माय डियर. प्रोसेसर के लिए मेमोरी एक्सटर्नल रहता है. प्रोसेसर के लिए मेमोरी एक्सटर्नल रहता है. दैट इज द मोस्ट फंडामेंटल पॉइंट आपको पता होना है. मेमोरी एक्सटर्नल रहता है, मेमोरी इनबिल्ट नहीं है. ये ऑन चिप नहीं है, उसके ऑफ चिप रहेगा. सिमिलरली सपोज इफ हैव ए माइक्रो कंट्रोलर. पर माइक्रो कंट्रोलर क्या होगा? पर माइक्रो कंट्रोलर इनबिल्ट रहता है मेमोरी. इनबिल्ट मेमोरी रहता है. इनबिल्ट मेमोरी होता है. दैट इज अ फंडामेंटल डिफरेंस, यू शुड हैव एन आइडिया. ओके, सो इसके अंदर एएलयू रहता है, कंट्रोल यूनिट रहता है, वैरायटी ऑफ रजिस्टर्स रहता है. सो ये रजिस्टर्स, of course, if you go for the 8085 microprocessor, you're having certain set of registers. If you go for 8086 microprocessor, you're having certain set of registers. Yes or no? अगर माइक्रोप्रोसेसर 8085 देखो तो उसमें AL, BL, CL ऐसा आएगा, सॉरी ABC आएगा, accumulator base ABCDEHL आएगा. If you go for 8086 microprocessor, आपको AX, BX, CX ऐसा आएगा. That is a processor specific. ओके ना? लेकिन हम जनरली क्या करते हैं, वो पर्टिकुलर रजिस्टर्स का ऐसा क्लासिफाई किया है. फर्स्ट रजिस्टर MER. प्लीज नोट डाउन दिस रजिस्टर्स फुल फॉर्म्स एंड देयर फंक्शनैलिटीज. प्रगति, आर यू फॉलोइंग एवरीबडी? थोड़ा सा आज का सेशन थियोरेटिकली होगा, क्योंकि कंप्यूटर ऑर्गेनाइजेशन आर्किटेक्चर इज पूरा थियोरेटिकल कॉन्सेप्ट्स है. आपको पहले कॉन्सेप्ट्स पर ध्यान रखो. एवरीबडी इज अंडरस्टैंडिंग माय डियर? पूजा कुमारी, एनी डाउट? सरकार, सुमन प्रसाद, जितने लोग सेशन को देख रहे हैं मुझे सेशन को रिस्पांस दीजिए बेटा. या इस फर्स्ट रजिस्टर मेमोरी एड्रेस रजिस्टर, इसका पर्पस क्या है? प्लीज नोट डाउन. मेमोरी एड्रेस रजिस्टर का पर्पस नोट डाउन. होल्ड्स द मेमोरी लोकेशन ऑफ द डाटा दैट नीड्स टू बी एक्सेस्ड. See, there are two registers. One is a MER register, other one is a MDR register. MER register अलग है, MDR register अलग है. Memory address register, memory data register. Memory address register, this holds the address of the instruction. Okay na? So holds the memory location of the data. Memory location of the data that needs to be accessed. Okay. Next, memory data register holds data that is being transferred to or from memory. Whatever the data that is going to the memory. At present आपने जो कुछ एड्रेस से आप डील कर रहे हैं उसका डाटा, okay, holds the memory location of the data. Where that particular data is present, that particular memory location is going to be stored in the memory address register. See, for example, I will tell you with an example, my dear. See, I will tell you with an example. If you see, this is our memory. Okay, so this is our processor. This is our processor. Okay, so this is our processor or CPU, you can take. So this is the memory, my dear, and this is address. These are our address units. Okay, dear. These are our address units. All of you are following? So if you take this as a memory location, this is a memory location called some 0300 or 0100. So this is the memory location 0100. Okay. Next, this is another memory location 0101. This is another memory location 0102. This is another memory location 0103. Like this. So at present, suppose let us take 0100 is having a data of 22. Okay. So now tell me what the MAR contains, what the MDR contains from this table. Please tell me. All of you please tell me what MER contains, what MDR contains. If the processor is going to access the 0100 memory location, and in the 0100 memory location there is a content called 22, what a MER will contain, what a MDR will contain, please tell me. Very good. MER contains, excellent Pragati. MER contains 0100, yes. MDR contains the data of that particular memory 22, my dear. So this is the way you have to expect the questions. They are not very processor specific, my dear. Instrumentation or EC people or electrical people microprocessor पढ़ चुका है, so they may be studying like registers like accumulator, base, count register, data register, program counter, stack pointer, data pointer, high, low. These all you have studied right in the microprocessor. Please come out of that area. Just a generalized way here. Actually, architecture is decided first, then uske baad uska type of CPU is fabricated. Okay, so that's the point. So this is MDR. Right now the processor is handling this particular 0100. What is the next instruction address? What is the address of the next instruction to be executed? What is the address of, suppose here I have the instruction called add. So what is the address of the next instruction? 0101. So that is going to be stored in the program counter, my dear. So program counter always holds the address of the next instruction to be executed, my dear. So that's what the PC. PC, what it holds, my dear? Program counter. Program counter contains address of the next instruction to be executed. So this program counter को हम 8085 में भी program counter बोलते हैं. 8086 में हमने 8086 में क्या बोलते हैं? Yes, excellent पूजा कुमार. 8086 में program counter same 8085 में भी program counter बोलते हैं. Do you remember? I think in microprocessor you have studied. This program counter को हमने क्या बोलते हैं? Your 8085 में, in 8085 you will call program counter. In 8086 we will call instruction pointer, I think, right? Instruction pointer in 8086 microprocessor. Have you come across this word? Please make a note of this point. In 8085 microprocessor उसको हम program counter बोलते हैं. 8086 में हम उसको instruction pointer बोलते हैं. Got it? 8085 microprocessor में program counter क्या दिखाता है? Address of the next instruction to be executed. 8086 में भी address of the next instruction to be executed. Same thing, my dear. In a microcontroller also program counter रहता है. Yes or no? Have you observed this? Program counter is present in 8085, 8086, 8051 microcontroller also. The reason is the architecture is decided first. That's what I am telling. Architecture comes first. Acha, processor while executing this instruction, there should be some other fellow who will be keeping track of the next instruction. While the CPU is accessing this instruction, see this architectural feature. You please try to understand the architectural feature. So CPU wants to handle this particular thing first. When CPU is handling this, there should be some other fellow called program counter. So the program counter should always guide the processor where to go next. Got it? So this is the logic. So somebody will decide this architecture. Suppose if the program counter is not there, CPU has to complete its operation and again it has to search for the address, then it has to decide. उसका time consuming process है ना, समझ में आपको? If there is no assistant for me, every time I have to go there, I have to get the brick and I have to construct a wall. One wall construction, one brick construction. And again I am going, I am getting one more brick and adding to the wall, constructing. Again I am going, I am getting the brick and I am constructing. It kills my time. Suppose by the time I am completing one brick pasting, if there is an assistant who can bring me the next brick to me, it saves my time, right? So while I am doing this execution, there is another fellow who will bring a brick to me. It speeds up my process. Yes, computer science के लिए भी use होता है. Basic subject use होता है बेटा. Computer science लोग भी attend कर सकते हैं. But इतना depth में नहीं जा रहा हूँ. Computer science के लिए भी use करता है. Okay? आपको benefit हो जाएगा. At a glimpse आपको basic idea आएगा. CO बोलो तो. All of you understood, my dear? ये question ऐसे भी पूछ सकते हैं. Which particular register is responsible for parallel processing in any CPU? Can you answer this question, my dear? Which particular register is responsible for parallel processing of CPU? इसी बच्चों के लिए बहुत important question है. which particular register is responsible for parallel processing in CPU? What is the answer? What is the answer, my dear? Program counter. So program counter always holds the address of the next instruction to be executed. Now once this instruction is executed, you will go to this, again the PC will be uploaded, updated to 0102. yes or not? So हमने PC को हम बोलते हैं, प्रोग्राम काउंटर को हम बोलते हैं डायरेक्टर. Please note down, it is called director to CPU. Director to CPU बोलते हैं. Please make a note of this. Director to CPU. It's a general thing, sarkar. डायरेक्टर टू सीपीयू बोलते हैं, माय डियर, डायरेक्टर टू सीपीयू. मजा आ गया? एक बार मुझे थम्स अप दिखाइए बेटा, ये बहुत फेमस क्वेश्चन है, मैं गारंटी दे रहा हूं. अगर आपने सीओ का और प्रीवियस आईएएस का, प्रीवियस गेट का, एक बार सीएससी का पेपर देखो, मिनिमम 4 to 5 टाइम्स ये क्वेश्चन आ चुका है. Which of the following register is responsible for parallel processing in CPU? Which of the following register is helping the CPU to save its time? Or program counter holds address of dash instruction to be executed, present instruction, next instruction. इतना नंबर ऑफ टाइम से क्वेश्चन पूछ लिया. एक बार थम्स अप दिखाए बेटा जितने लोग क्लास में हैं. जितने लोग क्लास में, अगर तो आपको एक कॉन्सेप्ट क्लियर है, तो प्रोग्राम काउंटर का कॉन्सेप्ट क्लियर है, तो मुझे एक बार थम्स अप दिखाइए प्लीज. चलो चलो माय डियर, एवरीबॉडी नोटेड? नेक्स्ट, व्हाट इज द नेक्स्ट इंस्ट्रक्शन? What is the next? CAR. CAR बोलो तो current instruction register. Current instruction during processing. This is must confusing. See, what is the fundamental difference between this CAR and PC? Can you tell me? Please try to understand. Please try to understand. CAR क्या है? PC क्या है? CAR अलग है, PC अलग है. CAR holds right now what is the instruction you are processing. That instruction. For example, मैंने आपको एक अच्छे example से देता हूँ. For example, here I am writing a instruction, my dear. General instruction. Suppose if I am using a move instruction, move a comma b, move a comma some number, okay na, some 20 number. Next, move b comma. Suppose if you are using the any 8085 microprocessor, let us take 8085 microprocessor, my dear. If I am using 8085 microprocessor, can anybody tell me MVI accumulator some value 22, right? Next MVI, next B23, ADI add a comma b. Suppose this is the instruction I am writing, HLT. Now see what is the concept here. So this is the instruction, this is the next instruction. Right now the processor is executing this instruction, suppose. Okay, you understand? But here one important point I want to tell you, that is a problem with this concept. So if you see, one second, I cannot write like this. I should not write like this. It's wrong methodology to write. So let me write here first, programming. Suppose आपके पास एक set of instructions है बेटा, set of instructions है. For example, your program is starting from 1000 location, from 1000 at a distance of 0100. Okay, एक बेसिक प्रोग्राम से मैं एक्सप्लेन करना चाहता हूं. वेरी गुड, वेरी गुड. सौरभ जी, मैं एक बेसिक एग्जांपल से स्टार्ट करना चाहता हूं, सो दैट आपको क्लैरिटी आएगा. बिकॉज वी विल ट्राई टू अंडरस्टैंड दिस पर्टिकुलर कॉन्सेप्ट ऑफ रजिस्टर्स विद रेस्पेक्ट टू आवर नोन प्रोसेसर, आवर 8085 माइक्रोप्रोसेसर. आपको पता है एड्रेस 1000:0100, 1000:0100, दिस बेस एड्रेस, इसको हम बोलते हैं बेस एड्रेस बोलते हैं, एंड इसको हम बोलते हैं इफेक्टिव एड्रेस बोलते हैं. क्या बोलते हैं उसको? बेस एड्रेस एंड इफेक्टिव एड्रेस बोलते हैं. Okay, suppose here I am writing an instruction, move immediate accumulator comma some 22. Can you tell me anybody what is the size of this instruction? ये instruction का size कितना है? 2 bytes होगा. एक आप कोड है, एक ऑपरेंड है. तो फंडास है. आपको पता है दिस इज ऑप कोड है, दिस ऑपरेंड है, 2 बाइट्स दे गया. सो नेक्स्ट इंस्ट्रक्शन स्टार्ट्स फ्रॉम 1000:0102 माय डियर. सो हियर मैं लिख रहा हूं मूव इमीडिएट b, 24. मूव इमीडिएट b, 24. ये भी 2 बाइट इंस्ट्रक्शन है, ऑप कोड है, ऑपरेंड है, 2 बाइट चले गया. सो नेक्स्ट साइज स्टार्ट्स फ्रॉम 1000:0102 हो गया, 103 हो गया, 104. add a comma b, add a comma b सपोज ए सिंगल इंस्ट्रक्शन. मैं इंस्ट्रक्शंस के बारे में भी बताता हूं, आज का टॉपिक वही है मशीन इंस्ट्रक्शन. नेक्स्ट उसके बाद एक साइज है 1000:0105, इधर आएगा आपको halt इंस्ट्रक्शन आ जाएगा. ओके ना बेटा, इट्स अ बेसिक प्रोग्रामिंग. नाउ टेल मी दिस इज द 2 बाइट इंस्ट्रक्शन, राइट? इट्स अ 2 बाइट इंस्ट्रक्शन. यहां से देखो दिस द ऑप कोड बोलते हैं. तो फर्स्ट कम्स द ऑप कोड हियर माय डियर, मूव इमीडिएट a. Next comes the 22 data. Okay, next here move immediate op code आएगा b. Next comes 24. Next comes the single instruction add a comma b. Next comes the halt. So the program according to the instruction size, one instruction takes 2 bytes here, क्योंकि एक मेमोरी लोकेशन पे आपके एक मेमोरी लोकेशन में you can store only 8 bits of the data. फंडास आपको पता है. So this is 0100, 0101, 102, 103, 104, 105 my dear. Okay, so now if you see MAR talks about what? Suppose the memory address. So what is the instruction now? Move immediate a is the instruction. That particular instruction is present at what address? 0100. Okay, when the MAR showing this, the PC shows what? The PC shows the address of the next instruction. Actually the next instruction starts from this move immediate b. So here comes 0102 my dear. So here comes 0102. So next instruction starts from move immediate b my dear. Is it clear? And while you are performing these arithmetic operations, right now current instruction register CIR holds what? Please tell me. CIR holds what my dear? करंट इंस्ट्रक्शन रजिस्टर होल्ड्स व्हाट? दैट इज व्हाट आई एम एक्सपेक्टिंग. अगर आपको एक प्रोग्राम दिया है, ऐसा प्रोग्राम देने के बाद एग्जाम में पूछेगा पीसी क्या होगा, एमएआर क्या होगा, एमडीआर क्या होगा, सीएआर क्या होगा. सीएआर क्या होगा बेटा? प्लीज टेल मी. सीएआर होल्ड्स व्हाट माय डियर? सीएआर होल्ड्स एड्रेस. नो, it holds the instruction my dear. That's what I want to tell. CIR holds no. CIR holds not address. Saurabh Singh wrong. That's what I want to tell. CIR, इसलिए नेम देखो CIR. Please note down CIR, current instruction register. It's not the address. Current instruction register. What is the current instruction? Right now that you are answering is move immediate A. So move immediate A is the opcode. So this instruction is stored in that particular. That means the machine code. A move immediate A is a language, right? उसका machine code रहता है ना, उसका machine code बोलते हैं 1s and 0s में रहता है ना. Excellent रौनक सरकार, अभी पता हो गया आपको? Do you understand my dear? How many of you understood my dear? Virus. क्लियर है? सबको क्लैरिटी आ गया? करंट इंस्ट्रक्शन रजिस्टर is this. All of you got the clarity or not? Everybody is clear. Actually speaking, move immediate A is a assembly language. उसका middle level code रहता है, उसका middle level language, उसका code रहता है ना machine code. उसका machine. Move immediate A के लिए कुछ code रहता है. Move immediate A के लिए अगर मूव इमीडिएट ए ने आपको मशीन लैंग्वेज में करो, मशीन लैंग्वेज में कुछ कोड रहता है 0110 समथिंग, हम कोड रहता है उसके लिए, वो कोड रहेगा. गॉट इट माय डियर? ऑल ऑफ यू अंडरस्टूड माय डियर? आई वांट टू टेल दैट आल्सो. इज इट क्लियर और नॉट? बेसिक थिंग है बेटा, वेरी वेरी बेसिक थिंग. Got it? Next, accumulator, what it will do? Accumulator, for example, at the end of this cycle, what is the result that you are going to get? That 22 plus 24, 46 will be coming into the accumulator. Accumulator is what? There are certain processes, there are certain architectures. A question ऐसा आ सकता है आपको इसी लोगों को, 8085 is a dash based architecture. 8085 microprocessor comes under which type of computer architecture? Is it a accumulator based architecture or is it a stack based architecture? 8085 comes under which type of architecture, my dear Sarkar? 8085 में అంటే कंप्यूटर आर्किटेक्चर मैंने ऐसे डिसाइड किया. सी दिस इज द वे यू कैन अंडरस्टैंड ईसी पीपल का एडवांटेज है. दिस इज द वे यू कैन अंडरस्टैंड द सीओ सब्जेक्ट. हमारा 8085 माइक्रो प्रोसेसर में क्या किया हमने, जो कुछ भी अरिथमेटिक ऑपरेशन करो, एडिशन करो, सब्ट्रैक्शन करो, मल्टीप्लिकेशन करो, कहाँ आता है रिजल्ट. और अगर आपने एक्सटर्नल पोर्ट से डाटा लेना चाहते हो कहाँ आएगा, और अगर आपने सीरियल डाटा कम्युनिकेशन करना चाहते हो तो कहाँ से स्टार्ट होगा डाटा. प्लीज टेल मी. इसी बच्चों आपको पता है, ये इसी बच्चों आपको पता है 8085 कोई माइक्रो प्रोसेसर है, सिंगल माइक्रो प्रोसेसर है, वेरी वेरी फेमस माइक्रो प्रोसेसर हमने पढ़ चुका है. अरिथमेटिक ऑपरेशंस के बाद रिजल्ट कहां आता. अगर आपने सीरियल डाटा कम्युनिकेशन करना है कंप्यूटर माइक्रो प्रोसेसर से कुछ डाटा बाहर को भेजना बोले तो कहां से जाएगा, एक फंडामेंटल रजिस्टर है, उसके लिए अक्यूमुलेटर बोलते हैं. दैट्स व्हाई 8085 इज अक्यूमुलेटर बेस्ड आर्किटेक्चर. समझ में आपको. सी दैट्स व्हाट द ब्यूटी ऑफ आर्किटेक्चर माय डियर. That's what the beauty of architecture. CPU, suppose if you see, there is one CPU called 8085. 8085 is a accumulator based architecture. Do you understand, my dear? That means a single fellow is going to rule, just like Salman Khan is ruling the Bollywood. So this accumulator fellow will rule. Got it, my dear? मजा आ गया. Even the 8051 also, my dear, 8051 also is an accumulator based architecture. So the concept behind this architecture is COA. पहले वो आर्किटेक्चर को डिसाइड करते हैं, आर्किटेक्चर को डिसाइड करने के बाद ये पूरा आएगा. और चलो 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 माय डियर, एवरीबॉडी हैज नोटेड. आप सब लोगों को क्लैरिटी आएगा. फिर एक बार मैं रिपीट करता हूं. मेमोरी एड्रेस रजिस्टर होल्ड्स द मेमोरी लोकेशन ऑफ डाटा दैट नीड्स टू बी एक्सेस्ड. हमारा इंस्ट्रक्शन में कुछ डाटा है, वो डाटा कहाँ है, वो एड्रेस में मेमोरी एड्रेस रजिस्टर. एमडीआर memory data register holds the data that is being transferred to or from memory. Right now which data is going to be taken from the memory or which data is going to the memory. Next, accumulator holds arithmetic and जो कुछ operations किया उसके बाद result जो कुछ आया. PC holds the address of the next instruction. CAR. So आपको पता है ऑलरेडी, आपने कंप्यूटर ऑर्गेनाइजेशन के पहले ही आपने माइक्रो प्रोसेसर पढ़ चुका है. सो जस्ट ट्राई टू कम टू द जीरो लेवल. इसके लेयर है आर्किटेक्चर. कंप्यूटर आर्किटेक्चर इज अ लेयर. ये लेयर के ऊपर सीपीयू आ गया. ट्राई टू अंडरस्टैंड. आपको घर बसाने के लिए क्या है, फर्स्टली प्लान करते हैं ना. आई वांट अ डुप्लेक्स, और आई वांट ए विला टाइप, और आई वांट ए रेस्टोरेंट मॉडल, और आई वांट ए ऑडिटोरियम मॉडल. सो पहले आर्किटेक्चर, उसके बाद कंस्ट्रक्शन. That's what the 8085 microprocessor is built upon accumulator. चलो माय डियर, ये तो फंडास है. जो कंट्रोल यूनिट सब कुछ डिसाइड किया मैंने. बसेस के बारे में आपको पता है. इसी बच्चों आपको पता है एड्रेस बस, डाटा बस, कंट्रोल बस. सो फाइनली हियर वन इंपॉर्टेंट पॉइंट आई वांट टू टेल यू. जस्ट an important point I want to tell you. There is one more architecture. See here. What is this architecture? Harvard architecture. ये हार्वर्ड आर्किटेक्चर डिफरेंस क्या है? अगर आपने वॉन न्यूमन आर्किटेक्चर से कंपेयर करें तो हार्वर्ड आर्किटेक्चर को देखो तो डिफरेंस क्या है? आई एम नॉट टेकिंग मच टाइम ऑन द बसेस, एवरीबॉडी नोस द बसेस. हार्वर्ड आर्किटेक्चर के लिए इंस्ट्रक्शन मेमोरी सेपरेट है, डाटा मेमोरी सेपरेट है. एज द इंस्ट्रक्शन मेमोरी सेपरेट, डाटा मेमोरी सेपरेट, उसके लिए बस सेपरेट है, उसके लिए एड्रेस बस सेपरेट है, उसके लिए डाटा बस सेपरेट है. यू अंडरस्टैंड? एंड डाटा मेमोरी सेपरेट है, उसके लिए एड्रेस बस सेपरेट है, उसके लिए डाटा बस सेपरेट है. सेपरेट बस फॉर डाटा मेमोरी, सेपरेट बस फॉर इंस्ट्रक्शन मेमोरी. सो देयर इज नो क्वेश्चन ऑफ शेड्यूलिंग. इसी बच्चों आपको ये पता है वर्ड शेड्यूलिंग एल्गोरिथम. इसी स्टूडेंट्स, आई थिंक ऑल ऑफ योर इलेक्ट्रॉनिक स्टूडेंट्स हियर, मोस्ट ऑफ ऑल द स्टूडेंट्स आर इलेक्ट्रॉनिक स्टूडेंट्स हियर. इलेक्ट्रॉनिक स्टूडेंट्स के लिए पता है शेड्यूलिंग एल्गोरिथम. आपने सुना कर्नल इन एम्बेडेड सिस्टम. शेड्यूलिंग करने के लिए भी एक एल्गोरिथम होता है. सो इधर ऐसा कुछ नहीं, शेड्यूलिंग करने की बात नहीं है. सो प्लीज मेक ए नोट ऑफ दिस पॉइंट. शेड्यूलिंग ऑफ द बसेस इज अवेलेबल इन व्हाट आर्किटेक्चर? Scheduling of buses is available in what architecture? In what architecture we are having the scheduling of the buses? Please answer me. आज का सेशन ऐसा ही होगा, आपको थियोरेटिकली रहता है, लेकिन ये थ्योरी पर आपको क्वेश्चंस आने के बहुत सारा चांसेस है। कहां बस का शेड्यूलिंग रहता है, विच आर्किटेक्चर में बस का शेड्यूलिंग रहता है, बताइए जल्दी। विच आर्किटेक्चर में आपको बस का शेड्यूलिंग रहता है बेटा, जल्दी बताइए। प्लीज टेल मी। Excellent. Von Neumann architecture requires scheduling. Remember this point. That is the expected question. That is the cream of the area. Von Neumann architecture requires scheduling. उसके लिए प्लान करना है, लेकिन इधर शेड्यूलिंग की प्रॉब्लम नहीं है, सेपरेट बस है. Okay. So now if you see certain futures, Von Neumann architecture and Harvard architecture. The best example I will tell you, EC people. Can anybody tell me which particular microprocessor or which device works on Von Neumann architecture, which device works on Harvard architecture? Can anybody tell me? प्रगति जी, रवि कुमार जी, आपके इलेक्ट्रॉनिक्स कम्युनिकेशन में हमने पढ़ चुका है. Which device works on Von Neumann architecture? Which device works on Harvard architecture? Please note down. 8085 microprocessor works on Von Neumann architecture, my dear. Whereas Harvard architecture 8051 microcontroller works on Harvard architecture. Microprocessors are following Von Neumann architecture fundamentally, majorly microprocessor, and microcontrollers are following Harvard architecture, my dear. So this is the area actually architecture began, my dear. Once architecture beginning होने के बाद उसके ऊपर आपको microprocessors, microcontrollers का era आ चुका है. तो पहले Von Neumann, Harvard, these are great professors, Princeton and Harvard. Actually there is a Princeton University, Harvard University. Princeton University में एक प्रोफेसर है Von Neumann, Harvard University में एक प्रोफेसर है Harvard. ये दोनों लोग 1939, 1945 सेकेंड वर्ल्ड वॉर टाइम में ये आर्किटेक्चर डिसाइड किया है, आर्किटेक्चर का डिजाइन किया है. सो माय डियर, फर्स्ट ऑफ ऑल आर्किटेक्चर्स, उसके ऊपर हमारा आईसीस चिप्स डेवलप हो चुका है. Okay, so microcontrollers like 8051, उसके बाद आपका general universal microcontroller. What is a universal microcontroller, my dear? Arduino. Arduino is a universal microcontroller. Atmega 328 microcontroller. And उसके ऊपर advanced microcontrollers like LPC2148 PIC microcontroller. ये पूरा architectures, ये पूरा devices are supported based upon these architectural features. So EC people, you must know. EC people, अगर आपने embedded systems आपका future के लिए choose कर रहे, if you are choosing embedded systems as your masters or you are choosing embedded systems as your journey, CA is a must and should subject for you. You should understand computer architecture, my dear. जितने लोग इधर embedded systems पर MTech करना चाहते हो, जितने लोग इधर embedded systems पर MTech करना चाहते हो, उसके लिए ये understanding बहुत important है. Von Neumann and Harvard का understanding बहुत important है. Okay, चलो my dear, if you see here, it's a theoretical design based on the stored program concept. Theoretical है. Next, this one, it is a modern computer architecture based on the Harvard. Okay, it's a modern one. Most important thing, it uses the same physical memory address for instructions and data. In code and data, same memory. It uses a separate memory for addresses and for data. Processor needs 2 clock cycles to execute an instruction. Most important, देखो, 2 clock cycles. Why? Because 1 clock cycle to access the program memory, 1 clock cycle to access the data memory, because they're inside. They're inside. आपका बस एक ही अटेम्प्ट में एक ही काम कर सकते हैं. एट ए टाइम आपका बस एक ही एक्शन कर सकता है. यस सर, नो? एड्रेस बस, डाटा बस, क्या करना है? एड्रेस बस, either it can access the memory or it can access the data memory or it can access the code memory, right? So everything is a RAM concept. The program memory and the data memory both are in the same RAM. But when it comes to here, processor needs one single cycle, क्योंकि इसके लिए RAM separate है, ROM separate है. Do you understand this point here? There is a RAM separate है, ROM separate है, my dear. The RAM comes here data, ROM comes here code memory. You understand? This is what the bootstrapping. Have you observed? Whenever you are using the microcontroller boards, whenever you are using the microprocessor boards or whenever you are using an Arduino board, at the center there is a chip, yes or not? That is a boot loaded program. We are going to load a program into that ROM. That's what we call as boot loading. Have you come across this word, ECE people? Yeah, that is what the code, ROM, separate memory, single cycle. You understand? Any doubts, please ask me. Chalo. Got it, my dear? Maza aa gaya? Yes. Sir, you using the 2 clock cycle into the von Neumann architecture, but in case of connecting data from external for sir, you using 2 clock cycle into von Neumann architecture, but in case of connecting fetching data from external, is this true for von Neumann architecture? When you are collecting, if the processor needs 2 clock cycles to execute an instruction, means that is what you have to switch the scheduling. That's what we have to decide the scheduling. That's what I'm telling, my dear. We have to give a scheduling allotment. That's what the timing diagram of microprocessor. If you study the timing diagram of microprocessor carefully, my dear, first comes the address bus accessing. In timing diagram of any processor, first comes the address bus. Address bus के ऊपर आप address place करना है. Then address bus goes on fetching for the address. Once the address bus is found, then data bus comes into picture. Until and unless address bus is free from its action, your data bus cannot do anything. That is what we call scheduling. That facility is not required in Harvard architecture. Got it, my dear? Yes. Chalo. Simpler control unit design and development of one is cheaper and faster. This is cheaper and faster क्योंकि आपने allotment कर रहे हैं, कुछ problem नहीं. लेकिन इसके लिए control unit is somewhat complicated, my dear, क्योंकि आपने control unit develop करना है ना. Control unit should handle the two things. Control unit should handle the two things, right? One control on the data memory, one control on the program memory. Next, see where it is used. First of all, von Neumann architecture used in personal computers, laptops and workstations, whereas it is used in microcontrollers and signal processing units. ECE बच्चों के लिए बहुत important है. टेक कंसल्टेंट आपका डाउट क्लैरिफाई हो गया, माय डियर? टेक कंसल्टेंट आपका डाउट क्लैरिफाई हो गया. Scheduling of the buses is required. Data bus has to wait until the address bus is over. You please check the timing diagram of any microprocessor. T1, T2, T3, T4 clocks. Address bus will be waiting there. Data bus will be waiting until the address bus action is over. Chalo. Data transfers and instruction fetches cannot be performed simultaneously. That's what I want to tell you. You cannot perform data transfer and also instruction fetching. But here it is possible. Data transfers and instruction fetches can be performed at the same time. It's a best slide which talks you about, which gives you the clear-cut information of Harvard architecture and von Neumann architecture. I hope all of you enjoyed this. All of you enjoyed this. Understanding is clear. Everybody understood the concept very clear, my dear. मैं इतना स्लो जा रहा हूँ ECE बच्चों के लिए. अगर ये क्लासेस पूरी नॉलेजफुल अटेम्प्ट किए तो आपको एक्स्ट्रा कंटेंट का जरूरत नहीं है. प्लीज फॉलो दिस लेक्चर्स वेरी केयरफुली फ्रॉम द वेरी स्क्रैच आई एम डिस्कसिंग. ऑल ऑफ यू फॉलोड, माय डियर? चलो, और कुछ एक्स्ट्रा कंटेंट है मेरे पास. सो दिस simple, I have given one more extra. Data and program are stored in the same memory. Data and program are stored in a different memory. It has only RAM for data and code. Remember this point. Remember this point. Can you specify then with fetching data? Can you specify then fetching data in 805 is different, is not used address bus? I didn't understand your question. Okay, we'll discuss that. I didn't understand the form. Can you specify? It's not used address bus. Chalo. Common buses for address and data here. Separate bus for address, data, code. I mean address के लिए separate address and data bus separate for data memory and code memory. Mean to say डाटा एक्सेस करने के लिए एड्रेस बस डाटा बस सेपरेट एंड कोड मेमोरी को एक्सेस करने के लिए एड्रेस बस डाटा बस सेपरेट. दैट इज अ पॉइंट आई वांट टू टेल यू. ओके, नेक्स्ट. कोड इज एक्सिक्यूटेड सीरियली एंड टेक्स मोर साइकिल्स. Sequential. Whereas code is executed in parallel with data, so it is less cycles, faster. That's what it is, faster, my dear. Next, data or code in one cycle. Data and code in one cycle. Data or code, please listen this point. Data or code in one cycle. This is data and code in one cycle. Data or code in one cycle. Either you can perform data related operation or program related operation. But here, data and code in one cycle. Please tell me here one important point, which requires more control signals. This is one expected question. Dear aspirants, I saw questions both confusing hai. Which particular architecture requires more control signals? Von Neumann architecture or Harvard architecture? Please answer my question. Which particular architecture requires more control signal? Which is more complicated architecture? Harvard architecture is complicated or Von Neumann model architecture is complicated? Please answer my question. Which is the most complicated architecture, either Von Neumann or Harvard? Harvard is the most complicated. Why? Because you need the two controllings. Because data memory is separate, code memory is separate. No, my dear, Harvard is the most complicated architecture. That's what I want to tell you. It looks simpler, but you need complicated architecture means behind you need control action on two blocks. There is one memory separate, other memory separate. Here your buses are accessing the code memory, here another set of buses are accessing the data memory. Separate bus is there, but the control unit is same. The control unit has to generate more actions on these two devices. Got it or not, my dear? Where the control unit is having more burden, that is what the most complicated architecture there, my dear. Please try to understand. Please make a note of this. Less control signals here, more control signals here. Have you noted? Less control signals, more control signals. Is it clear? Less control signals, more control signals here. All of you convinced, my dear? Harvard architecture is the most complicated architecture, my dear. उसके लिए ज़्यादा control action करना पड़ेगा. Control unit के ऊपर बहुत सारा burden लगेगा, because एक ही control unit है. Data memory separate है, code memory separate है. Data memory access करने के लिए bus signals available हैं separately, code memory access करने के लिए bus signals available है separately. लेकिन उसका पूरा control करने वाला unit एक ही है. So एक control unit के ऊपर इतना burden हो रहा है, इसलिए वो complicated हो रहा है. चलो next. चलो. Now the most instruction, this is the first topic of your COA subject as per the syllabus. Topic number 1. First topic, my dear. First topic, my dear. आपका GATE का syllabus का first topic machine instruction. I think all of you understood up to now these concepts. I think all of you are clear up to now, my dear. I think up to now everybody followed clearly or not? Chalo. Go through this. I will come in a minute. रेडी है सब लोग? चलो चलो, क्लियर है? आवाज क्लियर है? चलो, what is a machine instruction? So before starting the machine instruction, just a fundamental thing I want to tell you. See, there are three languages, my dear. Suppose if you are writing the basic program like include stdio.h, so this is our high level language. Yes or not? Include stdio.h, printf, hello program. So these are high level language, actually English, modern English language. So these are called very high level language. High level language. But whether your system will understand this high level language? No. Yes or not? So but the system, computer CPU, central processing unit, will it understand this language? Whatever the beautiful language you are writing, int, these are int I, j, for loop, while loop, whatever that you are mentioning in a C language, high level language, your particular computer will not understand. Your computer will understand only a language like this. Yes or not? The computer understands only a language in terms of ones and. This is what we call as machine language. What we call this as machine level language. Okay. So I will tell you one important point, my dear. I will tell you one important point. The C language comes under high level language. So it is a high level language. But the computer will understand zeros and ones and zeros. So this is what we call as MLL, machine level language. Machine level language. Machine level language. So there is a converter which converts the high level language to machine level language. So that is what we call as compiler. What is that? Compiler. So compiler will convert the English instructions to the machine understandable instructions. At the same time, there are certain instructions like this. What is this language? What is this instructions, my dear? What is this instructions? These are what instructions? So this particular instruction contains a semi-English language. Yes or not? These particular instructions will contain semi-English language. So this is what language? Can anybody tell me? This is what language? Please tell me, what is this language, my dear? Is it a high level language? No, it is an assembly language. ALP बोलते हैं उसको. क्या बोलते हैं उसको? ALP, assembly language programming. This particular assembly language is converted to ones and zeros. Machine always understand ones and zeros, and there is one more converter here. What is the converter name? The converter name is assembler. Assembler converts the assembly language to the machine level language. Clear hai? Compiler is a software, assembler is a software. Yes or not? Compiler and assembler both are softwares. Compiler converts high level language to machine level language. Assembler converts the machine language. Assembler converts the assembly language to machine level language. Is it clear? Now, this is our instructions. Generally, एक instruction का format कैसा रहता है? Instruction is a way to get the things done. Yes or not? So the basic thing. An instruction is a set of codes that the computer processor can understand. The code is usually ones and zeros. So ones and zeros को machine language बोलते हैं. Okay. For example, if you take the instruction, add is an instruction, jump is an instruction, load is an instruction. Okay. Now, in our particular architecture, let us talk again in terms of architecture. In the market, there are two types of designs based upon the instructions. Can you guess what are those two types? Based upon the types, जो type of instruction आप use कर रहे, उसके accordingly आपको computers को classify करते हैं. So उसको हम बोलते हैं CISC and RISC, my dear. So there are two types of instruction set. One is called RISC, other one is called CISC. Sorry, it's a mistake here, printing mistake. This is CISC. So this is what we call CISC. Okay. So what is the fundamental difference between the CISC and RISC? Let us see first. So first we'll start with CISC. First we'll start with RISC. Actually, I want to start with CISC first. I want to start with CISC. Yeah, first CISC. Complex instruction set computer. Please tell me what you understand by complex instruction set computer. One single instruction. Try to understand. One single instruction is going to do some sub instructions itself. You understand? A single instruction can perform n number of numerous low level operations. उसको कैसे understand करना है? Suppose if you are using an add instruction, if I am using an add instruction adds the two numbers. But internally what it is doing, my dear? Internally it is loading the number from one memory location, loading the another number from some other memory location, and it is performing the operation of addition. You understand? It is a single instruction. So that is what the complex instruction set of computers. See, CISC is a computer where a single instruction can perform numerous levels. Please make a note. A single instruction can perform numerous low level operation. That means, actually speaking, CISC architecture is trying to make reduction of instruction. Try to understand. CISC attempts to minimize the number of instruction. Always remember, if you follow the CISC, number of instructions will be less. That is the most important point. Suppose if you want to perform addition, this is CISC. A single addition will perform the addition of two numbers. But if you go to the low level of add बोलो तो first load some number, another load some number, then perform addition. So instructions ज़्यादा है generally, लेकिन उसको compress करके एक single instruction करता है, उसको हम बोलते हैं CISC. All of you understood this part. Many people are confused with CISC and RISC. Many students are confused with CISC and RISC. CISC बोलो तो एक single instruction is going to perform many low level operations inside, so that multiple people का जो कुछ task है एक single instruction perform कर रही है. इसकी वजह से number of instructions performed will be less. You understand? All of you understood this point, my dear? All of you understood? क्लियर है? ये बहुत क्लियर हो गया ना? नाउ टेल मी, CISC के लिए क्या करना है? बहुत आर्किटेक्चरल फीचर्स डिजाइन करना है. दैट मींस एक ऐड इंस्ट्रक्शन के पीछे क्या क्या आर्किटेक्चर्स है, ये आर्किटेक्चर बहुत कॉम्प्लिकेटेड रहता है. दैट्स व्हाई इट इज कॉल्ड कॉम्प्लेक्स इंस्ट्रक्शन सेट. एक सिंगल इंस्ट्रक्शन इज परफॉर्मिंग मेनी लो लेवल, a single instruction is performing many low level actions like load addition, load one number, load number 1, load number 2, then perform addition. So इसके पीछे बहुत सारा complicated architecture है. That's why उसको बोलते हैं complex instruction set computer. Is it clear, my dear? But if you see the RISC अलग बात है. RISC is different. A number of computer designers recommended that computers use fewer instructions with a simple construct so that they can be executed much faster with the CPU. So here the meaning here is not the number of instructions are going to be reduced, my dear. Don't confuse with the word. See, people ऐसा सोचते हैं CISC बोलो तो complex instruction set computer, so system का execution time इधर ज़्यादा होगा. Okay, RISC बोलो तो reduced instruction set computer, so instructions will be lesser here, so system का time अलग होगा. ऐसा सोचते, लेकिन इधर बात ऐसा नहीं है. CISC में number of instructions is actually less, लेकिन single instruction performs many low level actions. But here you are reducing the complexity. You are reducing the complexity means instructions are increasing. Vice versa. Try to understand. You are making many instructions to perform one action. समझ में आपको? So because of this, what happens now? Execution time of a single instruction is going to be reduced. A single add instruction may take many number of T states, but if you divide it into low level actions, load instruction, store instruction, like that, individual instruction, if you check, each instruction can take some amount of reduction in time. You understand this point? The concept of RISC involves an attempt to reduce execution time by simplifying the instruction set of computers. एक बात क्लियर हो गया, CISC and RISC के बारे में conceptually clear हो गया. You are not using a single instruction, you are using many instructions here so that the execution time of one instruction is going to be reduced. See here, relatively few instructions, relatively few addressing modes, memory access limited to load and store instructions majorly. All operations done within the registers of the CPU, single cycle instruction execution, fixed length, easily decoded instruction format, hardwired rather than micro-programmed control. That means per one clock cycle, per one T state, one instruction khatam. That is the most important point. That is a feature of RISC. But if you take CISC, one instruction can take n number of T states, my dear. That is the most important point you have to understand. One instruction is over in one T state. That means it is reducing the burden on execution. Whereas CISC, one instruction will take many number of T states. All of you understood. That's why it is complex. All of you got the clarity now, my dear. Simple बात मैं बोल रहा हूँ. Add you can take as a CISC instruction and उसको low level split करो, load store. Then it is a RISC instruction. Characteristic of CISC: a large number of instructions, typically from 100 to 250 instructions. And number of instructions ज़्यादा है. But in RISC, limited instructions है, but you are using them multiple times. You are using them multiple times. Here single instruction you are using, but single instruction takes much time here. Next, some instructions that perform specialized tasks are used infrequently. A large variety of addressing modes are available here. Instructions that manipulate operands in memory, variable length instruction formats. This is the one of the important point, variable length of the instruction. Okay. The example दिया मैंने, एक example. For performing an add operation, CISC will execute a single add command which will execute all the required load and store. RISC will execute each operation for loading data from memory, adding values and storing data back to the memory using different low level instruction. That is a fundamental feature. One add instruction itself will perform many low level operations in itself. That is CISC. But RISC means first load, then store. Okay. So now let us talk about the instruction format. Now actually all of you somewhat theoretical session को लिया है अभी. Now we are entering into the actual session. एक बार मुझे thumbs up दिखाए. Up to now आपको clarity आ गया. I think all of you got some good clarity on CISC and RISC. Everybody got some good clarity on CISC and RISC, my dear. चलो. Now instruction का format कैसा रहता है? Instruction का format ऐसा two fields रहता है. One is the opcode field. This is the opcode field, my dear, and these are the operand field. Majorly instruction को ऐसा split कर सकते हैं, my dear. एक बार मुझे thumbs up दिखाए बेटा. आज अभी actual content को जा रहे हैं हम, gate का content को जा रहे हैं, which actually we can expect. Up to now whatever we got is a theoretical area, but here there is a possibility of getting some numericals also. This is the opcode and this is the operand. Operand can be registers. Operand can be, what are the operand? Opcode means what? Opcode is an instruction. Opcode is an instruction or opcode is a code. Example, for example, like add. Operand can be what? Operand can be registers, register or registers. Operand or operands. Operand can be a memory. You understand? Memory location कोई भी हो सकता है. Got it? So here, based upon the fields, how many fields you are having, how many addresses you are having. Operands को इधर address भी बोलते हैं. क्या बोलते हैं इसको? Operand को address भी बोलते हैं. How many number of addresser that you are using, based upon हमको instruction format को 3 address instruction format, 2 address instruction format, सिंगल एड्रेस इंस्ट्रक्शन फॉर्मेट, जीरो एड्रेस इंस्ट्रक्शन फॉर्मेट में डिवीजन किया है. सो फर्स्ट कम्स है, सपोज फॉर एग्जांपल आई हैव गिवन a CPU supports 8 bits instructions. What does it mean? Please tell me. A CPU supports 8 bits instructions. What does it mean? उसका मतलब क्या है? A CPU supports 8 bits instructions. That means instructions means it is related to opcode. Try to understand, my dear. Instruction means what? Opcode. That means the size of the opcode is 8 bits. You understand? 8 bits instruction. Size of the opcode कितना हो? Sorry. Size of the opcode कितना होना है? That means it is opcode size कितना होना है? Opcode size कितना होना है? 8 bits instructions आने के लिए, that means 8 type of instructions आने के लिए आपको कितना digits होना चाहिए? Opcode size कितना होना चाहिए? So your opcode size 3 bits होना चाहिए. 00, 001, 010, 011, 100, 101, 101, 110, 111. So the size of the opcode, अगर आपका size of the opcode is equal to 3 bits. You understand? अगर size of the opcode 3 bits है तो आप how many number of opcodes को access कर सकते हो? 2 power n ना. So this can be one instruction, this can be some instruction 1, this can be instruction 2, this can be instruction 3, some code I am telling, instruction 3, my dear. Try to understand. This opcode bits will represent, the size of the opcode bits will represent how many number of instructions can be answered by this particular architecture. Try to understand, my dear, carefully. If opcode size is 8 bit or if opcode size is 3 bit, then the number of instructions is equal to 2 power 3, my dear, or number of opcodes will be 2 power 3, my dear. Please make a note of this point. Try to understand. This area is an important area where you get a question. Opcode size represents 3 bits. Opcode size अगर 3 bits है तो आपने कितना instructions को access कर सकते हैं? 000. It can be a code for some move instruction. All of you following, my dear? It can be a code for move instruction, or it can be a code for some MVI. It can be a code for add. It can be a code for sub. It can be a code for load. It can be a code for store. It can be code for halt. It can be code for some AND logic. That means this particular instruction format is supporting how many instructions? 8 instructions. Got it up to you? All of you clear, my dear? Any doubts? So that's what I want to tell you, my dear. This is the total size of the instruction. Size of the instruction is, this is the instruction size. This is the size of instruction. This is the size of opcode. This is the size of operand. Try to understand. Size of instruction, this opcode size, operand size. Operand can be 2 address, 3 address, 1 address, 0 address. Suppose operands I am having 3 address. So that is, this is address 1, this is address 2. Suppose you take, this is address 3. This address 1, address 2, address 3. These are the 3 operands. This can be registers. They can be register, memory register, or this can be memory register, like that. But this is opcode. This opcode is opcode code. You understand, my dear? All of you clear? What is the size of instruction, my dear? Size of instruction is equal to summation of size of opcode plus operands or address fields. Address fields. Field or fields. Is it clear, dear? Please all of you note down. All of you note down. इसके ऊपर क्वेश्चन आने की चांस है. size of instruction is size of opcode plus address fields. Got it clearly? चलो अला फिर फॉलोइंग मुझे थम्स अप दिखाइए बेटा. एवरीबडी प्लीज शो मी थम्स अप, बिकॉज इतना कोर टॉपिक को हम जा रहे हैं. जस्ट इन द सिंपलेस्ट वे आई एम एक्सप्लेनिंग. नाउ हाउ मेनी एड्रेस आर देयर हियर? हाउ मेनी एड्रेस आर देयर हियर? 3 एड्रेस. अगर 3 एड्रेस है तो उसको हम बोलते हैं 3 एड्रेस इंस्ट्रक्शन बोलते हैं. क्या बोलते हैं उसको? 3 एड्रेस इंस्ट्रक्शन बोलते हैं. You understand? If there are 2 addresses, then 2 address instruction बोलते हैं. If only single address instruction बोलते हैं. If there are no addresses, then हम बोलते हैं 0 address instruction बोलते हैं. Clear? 0 address instruction बोलते हो केवल opcode रहता है. That's it. केवल opcode रहता है. No operands. समझ गया आपको? Just like halt instruction. पता है आपको halt instruction? HLT, NOP, I think you have studied HLT, NOP in microprocessor. These are what? There are no operands. You understand? That's it. So, now let us go through some understanding. See, for example, this is based upon what? Based upon the size. Based upon the size and based upon the type of operand. Based upon the type of operand क्या है? Based upon the type of operand one classification. Try to understand, there are 2 classifications based on the operation. Suppose that particular instruction may be arithmetic related, so it comes under arithmetic operation. Based upon the data transfer, move, load immediate, load accumulator, these will come under data transfer type. कोई भी माइक्रोप्रोसेसर ले हो, कोई भी माइक्रो कंट्रोल ले हो, आपको ये इंस्ट्रक्शन तो होगा, केवल ये फॉर्मेट अलग अलग हो जाता है. बेस्ड अपॉन द टाइप ऑफ ऑपरेशन, डाटा ट्रांसफर एक टाइप है, अरिथमेटिक लॉजिक एक टाइप है, मशीन कंट्रोल एक टाइप है, इटरेटिव एक टाइप है, ब्रांच कंट्रोल एक टाइप है. डाटा ट्रांसफर बोलो तो डाटा ट्रांसफर बिटवीन द रजिस्टर्स, रजिस्टर टू मेमोरी, मूव ऐसा आएगा. अरिथमेटिक बोलो तो ऐड, सब, एंड, और आएगा. अरिथमेटिक एंड लॉजिक. मशीन कंट्रोल बोलो तो एंड इंटरप्ट, एनेबल इंटरप्ट, डिसेबल इंटरप्ट, पुश, पॉप, ये मशीन कंट्रोल पर आएगा. इटरेटिव इंस्ट्रक्शंस, लूप, दिस ब्रांच कंट्रोल, आपको पता है. आपको we are not entering to that zone, my dear students, ECE बच्चों, we are not discussing about the microprocessor instructions here. Please keep in mind, this subject CO is not to discuss about the microprocessor instructions. I am not going to explain how EI will work, how JNZ will work, how POP will work. That is not our subject. We are high level, we are talking about the category of instructions. The most second one is the based upon the operand information. That's what I told you. Based upon the operand information, क्या बोल दिया मैंने? Based upon the address instructions. What are the address instructions? I told you 3 address instruction, 2 address instruction, 1 address instruction, 0 address instruction. Clear? In 3 address instruction, how many operands are there? 3 operand fields are present. 3 operand fields are present. Operand or address same, my dear, here. Don't confuse. In CO language, operand field, address field same है. Clear है? Next here, 2 address बोलो तो क्या है? 2 operand fields. That means syntax, 1 address बोलो तो 1 operand field. 0 address बोलो तो 0 operand field. उसका syntax का, उसका format कैसा होगा? So these are 3 operand field. 3 operand field में opcode तो पक्का होगा, and operand 1 होगा, operand 2 होगा, operand 3 होगा. नेक्स्ट 2 ऑपरेंड बोलो तो केवल हाउ मेनी एड्रेस होगा? 2 ऑपरेंड्स. ऑलवेज रिमेंबर, ऑपकोड तो पक्का होगा, ऑपकोड को छोड़ दो. दिस इज ऑपकोड, दिस इज ऑपरेंड 1, दिस इज ऑपरेंड 2. नेक्स्ट वन इज one address instruction. That means 1 opcode and 1 operand. That's it. Now listen carefully. All of you understanding this point or not, my dear? Please tell me. So this is opcode always. This is opcode. This is address 1, address 2. This is address 3. Clear? This is opcode. This is address 1. This is address 2. This is opcode, and this is address 1, that's it. Here opcode, that's it. All of you understood, my dear? Is it clear? Everybody. And remember, size of the opcode will give what information? Size of the opcode will give what information? The number of opcodes. Okay na? Size of the opcode will give you the number of opcodes. Number of opcodes bolo to number of instructions that is supported by this architecture. Please make a note of this point, my dear. 1 second I am telling. Okay na? First let us start with 3 address instruction. 3 address instruction आपको understand करने के लिए मैं एक अच्छा example भी दिया. In 3 address instruction, this opcode, address 1, address 2, address 3. See, this address 1 is some machine code only. Actually, address 1 can be a register. See here, address 1 is a register. Address 2 is also register. Address 3 is also register. And opcode is add. Add ka opcode 10101. What is the instruction? The instruction is add R1 comma R3 comma R2. Do you understand, my dear? In microprocessor, you cannot find this type of instructions. All of you are following? In microprocessor, you cannot find all type of instruction. Here in architecture, I am showing. Address add R1 comma R3 comma R2. इसका मतलब क्या है? R2 contents will be added to R3 and the result will be stored in what? R1. This is a point. Yes or not? This is architecture. Now dear, here this is the opcode. This opcode is having how many bits here? Dekho. Opcode is having how many bits? Please tell me. Opcode is having how many bits? Tell me. 1, 2, 3, 4, 5. Opcode is having how many bits? Please tell me fast. Opcode is having how many bits? What is the size of opcode in this? For example, size of opcode कितना है? सरकार, size of opcode कितना है इधर? Fast. Add instruction है, add instruction का machine code है 0101 like that. Then what is the size of opcode? Size of opcode, I am asking you the size of opcode, my dear. Excellent. Size of opcode 5 है. Address field, the A field का size कितना है? 2 bits. 2 है. And इसका size कितना है? 11 है. And इसका sorry, it is also 2. Sorry, it is also 2. It is also 2. So total instruction का size कितना हो गया? Total instruction का size 5 plus 2 plus 2 plus 2, 2 plus 2, 4 plus 2, 6 plus 5. Instruction का size कितना हो गया? 11 bits. You understand? Got it? Chal. Now, let us go for one more. See here. 2 address instruction. In 2 address instruction, we are having opcode address 1, address 2. Clear? So best example here, I will give the instruction like this: add R1 comma R3. The contents of R3 are added to the contents of R1 and the result is stored in the R1. Okay. So here one of the operands itself is used to store the result. Got it? One of the operands itself is used to store the result. Maza aa gaya? One of the operands itself is used to store the result. And the next one address instruction. One address instruction means what? See here. This is add R1. Only one address field, opcode to same hai, add R1. Now tell me, this is what does it mean? Add R1 means what, my dear? One operand is R1. What about the other operand? What about the other operand, my dear? Please tell me, fatafat. In one address, single address field, that means other than opcode, there is only one address field. Only one address field. What about the other operand? अरे यार, addition करने के लिए हमको 2 places होना चाहिए. Now R1 is there, register 1 is there. What about the other? Anybody can guess? Here is a most important objective question is possible. Excellent. Accumulator, and where the result is going to be stored, my dear? Where the result is going to be stored? The result is going to be stored again in the accumulator. That's why one address instruction supports which base architecture? It supports which based architecture? It supports the accumulator based architectures, my dear. Please note down a question. Please note down, this is important, accumulator based architecture. It supports accumulator based architecture. Accumulator based architectures are what? 8085 microprocessors. Yes or not? The 8085 microprocessor supports this. You can find such type of instructions there. Add immediate B. You can find this type of instructions there. sorry. Add immediate 12. That means the 12 will be added to the A and the result will be stored in A. Got it? Chalo. Next. Last one is the zero address instruction. Zero address means no any address instruction, keval opcode. You understand? The best example I will tell you, push. This type of single opcode, these are going to be zero address operands. They are going to support the stack based operations, stack based architectures, my dear. Please note down, zero address instructions are going to support what architecture? Stack based architecture. Clear? That means that I mean to say, it is going to support the architecture in which stack is present. These particular instructions are supported in architectures where the stack is present. That's why we call stack based architecture. Of course, 8085 also supports stack based architecture. Chalo. Now we'll go with some set of questions so that we can get some idea. See here. Now try to understand this question. Try to answer this question, my dear. Please answer this question number 1. Consider a digital computer which supports 3 address instructions, each with 21 bits. If address length is 6 bits, then the maximum and minimum, how many instructions the system can support? What is the answer? How to solve this question? Consider a digital computer. This is an expected model questions, my dear ECE people. Try to understand and try to answer the question. What is given? He has given a digital computer which supports 3 address instructions, my dear. There is a 3 address instructions format. So let us take the 3 address instruction format. Yes, 3 address instructions. So 3 address में क्या क्या आएगा? So this is our opcode 3 address, address 1, address 2, address 3. So let us take this, the opcode. This is address 1. Okay, I will write inside. This is opcode. This is address 1, address 2, address 3. Okay, what is given? Consider digital computer which supports 3 address instructions. Like that, many instructions are 3 address instructions, each with 21 bits. That means what? The total number of bits is how much? The total number of bits is how much, my dear? What is the size of the instruction? Very clearly as given, the size of the instruction is 21 bits. Please note down. Size of instruction is how much? 21 bits. Next. Address length is 6 bits. So this is 6 bits. This is 6. This is 6. this is 6. Okay na? Correct na? 666. Size of address length is 6 bits. If address length is 6 bits, then what is the opcode size, my dear? पता है ये opcode size कितना होगा? So address size is how much? 6. So 3 into 6, 18 gone, 21 minus 3 into 6 gone. So the remaining will be what? The size of opcode na? You understand any mistake we are doing? So size of opcode कितना आएगा? Size of opcode कितना आएगा? 3 bits. So if the size of opcode is 3 bits, that means opcode size is 3 bits. So what is the minimum number of instructions and what is the maximum number of instructions? If the size of opcode is 3 bits, so the maximum number of instructions, maximum number of opcodes will be how many? 2 power n. That means 2 power 3. That means 8. So minimum number is what? Minimum number of opcodes is 2 power 0. 2 power 0, that is equal to 1, my dear. That means minimum तो 1 instruction होना है ना. कोई ना कोई आर्किटेक्चर मिनिमम तो मिनिमम एक इंस्ट्रक्शन को सपोर्ट करना है. सो मिनिमम इज 1, माय डियर, नॉट 0. रवि कुमार, अगर वो कंप्यूटर इज नॉट एबल टू एक्सेस 1 इंस्ट्रक्शन आल्सो, देन व्हाट इज द यूज ऑफ दैट कंप्यूटर? रवि कुमार, minimum is 0. How? Minimum is 1, my dear. Remember that point. Minimum cannot be 0. Minimum cannot be 0, my dear. Minimum is 1. Minimum to minimum. At least opcode itself is a instruction na. Yes, opcode itself is a instruction हो सकता है. Listen, my dear. A 3-bit instruction, 3 address instruction automatically supporting 2 address instruction. A 3 address instruction automatically supports 2 address instruction. A 3 address instruction automatically supports 1 address instruction. A 3 address instruction automatically supports 0 address instruction. Do you understand? This is a 3 address instruction. Suppose if I have not given any field in this, it becomes a 2 address instruction. Or I can give this and this. Suppose I have given here R1, R3, I have not given anything. Or I have given R1, R2, I have not given anything. Okay, so I have not given these two, then it becomes a 3 address instruction supports internally 2 address, 1 address, 0 address. A 2 address instruction internally supports 1 address, 0 address. A 1 address instruction internally supports 0 address. At last 0 address instruction, at least 1 instruction is there na. At last 0 address instruction, that is केवल opcode. That केवल opcode एक 1 instruction हो गया ना. So minimum कितना हो गया? Minimum 1 हो गया, maximum 8 हो गया. मजा आ गया बेटा? This is a minimum, this is a max. This is the area बेटा. इसके ऊपर कितना सारा क्वेश्चन आने की चांसेस है. अगर प्रीवियस सीएससी ब्रांच का आईएएस का पेपर, गेट का पेपर देखे तो यही मॉडल पर आपको इतना सारा क्वेश्चंस आ गया. समटाइम्स ही विल गिव दिस एंड ही विल आस्क दिस, समटाइम्स ही विल गिव ऑल एंड ही विल आस्क टोटल साइज, समटाइम्स ही विल गिव ऑपकोड साइज, एड्रेस साइज, ही विल आस्क टोटल बिट्स. शफल करते जाओ. मजा आ गया? चलो try to answer this question. Question number 2. Question number 2. फास्ट. सरकार जी क्लियर है? सेशन को लाइक करते जाओ, सेशन को एंकरेज करते जाओ बेटा. Consider a digital computer which supports 32. There is a 32 2 address instructions. ante number of instructions is 32 and the instruction को हम बोलते हैं 2 address instruction बोलते हैं. 2 address instruction. That means the instruction is having 2 address fields. If address length is 8 bits, then the length of the instruction is dash bits. Length of the instruction is dash bits. Dash bits. Please answer this question फटाफट. डैश इधर आना है. Answer please, I'm waiting for your answers. So what is given here? First of all, it's a two address instruction. Two address instruction का format कैसा होगा? Whatever may be the instruction, opcode तो पक्का होगा. Opcode के बाद two address fields are there. That's it. So this is the opcode. This is the address 1. This is the address 2. Okay. Chalo. Consider a digital computer which supports 32 two address instructions. That means what is this 32? Can anybody tell me what is this 32? This 32 represents what? 32 represents what, my dear? I am expecting what is this 32 represents? What is that number 32 represents? What is the 32 represents? What is the 32? 32 is what, my dear? 32 is representing what? I am asking you, which supports 32 two address instructions. Total length, wrong. If total length is 32, then what is the length of the instruction? His answer is 32, na? No, 32 is not the length. 32 is not the instruction length. It supports 32 two address instructions. 32 instructions. Excellent. It's 32 is what? The number of instructions. Confuse हो गया? हाँ, अभी मजा है क्या? Number of instructions is 32, my dear. Number of instructions is 32 means automatically number of opcodes. Number of opcodes is 32. Number of opcodes is 32 means size of the opcode. All of you understood? Instruction and is it clear or not? 32 is clear, everybody first? Please tell me, beta, everybody 32 is clear or not? Please show me thumbs up. Everybody 32 is clear or not? I support 32 instructions. That's it. It supports 32 instructions. It supports 32 instructions. Very good. The size of the opcode 5 hoga. That's it. If the size of the opcode is 5, this is 5. And what it's mentioning, if address length is 8 bits, this is 8, this is 8. Then what is the total size length of this? Size of the opcode is 5. Size of address field 1, 8. Size of address field 2, 8. So total कितना होगा? Total size कितना हो गया? So total size of instruction कितना हो गया? 8 plus 8, 16 plus 4. आंसर कितना है? मजा आ गया? मजा आ गया बेटा? Now I think you can practice such type of questions. Got it, all of you? Enjoying? Everybody clear? Last question for today's class. Try to answer. This was a GATE 2016 CSC department question है. Computer science में पूछ लिया है question को. Try to answer this question. CSC department का question है. GATE 2016 का question है. A processor has 40 distinct instructions. And 40 instructions. That particular processor supports 40 instructions. Number of instructions is 40. And 24 general purpose registers. 24 general purpose registers. It is number of registers. A 32-bit instruction word, that means 32-bit is the size of the instruction, has an opcode 2 register operands and an immediate operand. That means it comes under which category of instruction? The instruction is having one opcode, 2 operands, register operands, and 1 immediate operand. That means what? It comes under which category? It comes under 3 address category, 2 address category, 1 address category, 0 address category. First tell me that instruction format comes under which category? Tell me, it comes under 3 address category, 2 address category, 1 address category, 0 address category. Yes, very good, 3 address category, because it contains one opcode, 2 register operands, and 1 immediate, 3 operands. So what is this? This is opcode, this is register 1, this is register 2, and this is some immediate बोलो तो some number, immediate data हो सकता है. Immediate addressing mode पढ़ा ना आपने माइक्रो प्रोसेसर में immediate addressing mode पढ़ लिया ना, एक नंबर देता है तब. Yes. What is the information given here? देखो ध्यान से सुनो. Number of instructions how many? Number of instructions how many? 40, my dear. Number of instructions 40 means number of opcodes same है ना, 40. That means what is the size of opcode? Please tell me, what is the size of opcode? It's over almost 9:30. I'm closing, just 5 minutes. Size of opcode जल्दी बताओ बेटा, मुझे भी भूख लग रहा है, जल्दी बताओ size of opcode क्या है? Can I take size of opcode as 5? My dear, if I take size of opcode 5, will it cover 40 instructions? अगर आपके पास 5 बिट्स हैं, 5 बिट्स से आपने 40 इंस्ट्रक्शंस को क्रिएट कर सकते? 0 0 0 0 one instruction, 0 0 0 1 second instruction, like no. 5 is wrong, right? Number of, if you take 5 means 2 power 5, 2 power 5 means 32, 32 means you are missing 8 instructions. That's why if you take 6, 2 power 6 64, 64 में आपने 40 यूज कर रहे, 24 unused, 24 आपने यूज नहीं कर रहे, लेकिन 6 is the perfect thing. Am I right? So size of the opcode मिला 6, so लिखो here size of the opcode 6 आ गया. Similarly, number of registers how many? Number of registers how many? 24. Number of registers 24 बोलो तो size of register means what? Are the bits required? Bits required for the size of register. I mean to say bits required for register formation is how many? 24. Same like 24 registers formation करना है, 24 registers. That means size of register बोले तो confuse हो जाता आप. It's not about the size. How many bits होना है? Very good. 6 bits है तो आपने 64 opcodes को create कर सकते हैं. 24 registers create करने के लिए అంటే 0 0 0 1 register, 0 0 0 1 another register, 0 0 1 0 another register. So कितना होना है बताइए जल्दी. Number of bits required for register formation 24. No, 24 is a number of registers. That means register 1. See, for example, if I take 0 0 0 0 0, this is representing the code for register 0. Next 0 0 0 1, this is representing register 1. Like that, if I take 1 1 1 1, it representing what? Register. Very good. If you take 5, it is going to represent 5 32. 2 power 5 32 now, this is 32. So this is R32. If you take 4, Suppose if you take only 4, it is going to come up to 16. Got it? So number of bits required for register is 5. Is it clear, my dear? So 0 0 0 represent R0 0. समझ में आपको? Try to understand the bits required for register formation. Got it, all of you? So आपके पास 5 bits हैं, 5 bits से आप 32 bits 32 registers को address कर सकते हैं. I can code like this 0 0 0 0 R0, 0 0 0 1 R1, 0 0 1 0 R2, like that. Okay ना? तो अगर मेरे पास लास्ट 1 1 1 R32 को भी एक्सेस करता हूं, लेकिन मुझे कितना चाहिए? 24 चाहिए. 2 power 4 16 को जा रहा है. If I take 4 bits, I can answer only 16 registers. If I take 5 bits, I can answer 32 registers. मुझे 24 चाहिए. So this का size 5 चले गया, this का size चले जाएगा. That's it. And what is the size of the instruction he has given? Very clearly has mentioned a 32-bit instruction. That means the size of the instruction he has given as how much? Size of the instruction is given as how much? 32 bit. So this is a 32 bit, right? Got it? 32 bit size. Now what is the immediate operand field? फटाफट आंसर बताइए. 6 plus 5 plus 5. This 10 plus 6 16. So the operand size, immediate operand कितना होगा? 16 होगा. What is the answer? Is it clear, my dear? Is it clear? What is the answer? 16. 16 bits. All of you got the answer, my dear? All of you understood? मजा आ गया? All of you enjoyed the session? So you got some confidence what type of questions are expected in the CO? Thank you. चलो. My dear aspirants, ये है हमारा pool of faculties from the GATE Wallah. See, this is a list of faculties. You can see the great personalities here. Many of them are ex-IAS officers. Many of them are already secured the GATE rank many times, and many of them are having a teaching experience of more than 10 years. So here you can see Chandan sir, who is teaching the digital electronics for ECE, and Naveen sir for EDC, Vishal Soni sir taking multiple subjects like maths, control systems, Varun sir for machines, Amulya Ratan sir for the aptitude, okay, and Sujal sir is taking signals, Sonu Lal sir is taking EMT, Siddharth Sabharwal is taking analog electronics, and me for EC people I am going to take computer organization architecture in a descriptive way for the paid batch students, computer organization architecture, and Ajay Gupta sir is taking some power systems, power electronics, Deeptanshu sir is taking care of networks. So pool of faculties are available आपको, अगर वो live class हो, paid class हो, free session हो, YT YouTube crash course हो, recorded content हो, one shot series हो, तो आपको एक number of pool of faculties are there. So all of you, if you are anybody interested to join the descriptive course of paid batch, okay, you can immediately contact the, okay. तो आज के लिए बस है सेशन. ये सेशन मैं एंड करना चाहता हूं. इस सेशन के बाद आपको एक पूरा पीडीएफ मिलेगा. पीडीएफ के साथ साथ एक डीपीपी भी मिलेगा, डेली प्रैक्टिस बिट्स. सो द डीपीपी मे बी बियॉन्ड द एक्चुअल टॉपिक आल्सो. व्हाई? बिकॉज समटाइम्स आई विल क्रिएट सम क्वेश्चंस वेयर यू हैव टू रिफर. ओके, आप रिफर करना है, रिफर करके प्रैक्टिस करके आ जाओ. ओके, तो सेशन को लाइक कर दीजिए, शेयर कर दीजिए. आई विश यू गुड लक. Tomorrow again at 7:30 we'll meet with a new topic. Okay, so please share your comments, please share your constructive comments in the commentary box. And अगर आपने DPP solve किया तो DPP solve करने का process में आपको which questions you are having doubts, that also you can post in the comment box. Those questions tomorrow I will discuss. Thank you very much. Love you all. Take care. Jai Hind.